everybody. This is course code MaEd-2361. Course title Calculus 2, which is given for second year first semester. It has 4 chapters. So we'll start for the first chapter, which is deal with the limit of function and continuity. So this is the first time. So this is applicable for the other department for mathematics, second year first semester. Also environmental science, second year first semester. So in a limit, it is starting point. It is the first chapter, which deals or starting concept of for the calculus. It is a bridge for the derivative and integration. So we have to define some terms, and we'll see again how to evaluate the limits of a different function. So it must be see for the definition of the limits in a sense. So it has two types of definition: the informal definition and the formal definition. So limit means it is written in such form, which is such form, or it has such formula, which means that this read as x approaches a, but x approaches a means it does not mean x equals to a. Instead, which means that x approaches a from the left, which is denoted by this one, and x approaches a from the right, which is denoted by this. The same is true f of x, or the given function approaches L, read as f of x approaches L, but f of x approaches L means it does not mean f of x equals to L. Instead, which means that f of x approaches L from the upper, and f of x approaches from the lower. Which means that if you look from the diagram, this is simply we can define using graphically what we have said for this. But bear in mind, x approaches a means it is not x equals to a. The same is true, the given function as x approaches a, again the given function approaches L. So example, limit of x plus 1 as x approaches 2 is equals to 3 means as x approaches 2 means we have 2 chances. As x approaches 2 from the right, again x approaches from the left, and also as x approaches 2 from the right in the sense if x approaches or values between 2 and 3. For example, 2.1, 2.01, 2.001, 2.001, and so on. Someone can choose this, and as x approaches 2, someone can use this. As x approaches 2, in a sense, generally, when x approaches 2 from the right, which means that numbers between 2 and 3. Any numbers between 2 and 3. The same is true as x approaches 2 from the left, means when x approaches values between 1 and 2, for example, 1.9, 1.99, and so on. And this is not fixed. Someone may choose this 1.8, and another may choose this one. In general, x approaches 2 from the left means between 1 and 2. The same is true for that one. When you substitute, since the given function is x plus 1, when we substitute values from the right, which means that this value f of x at f of x at 2.1, when substitute instead of x 2.1, then plus 1, 3.1. When you substitute 2.01, 3.01, and so on. This is the values of the function when substitute the value of x as x approaches from the right. The same is true. These are the values of the given function or approaches to these values as x approaches from the left. Now, we observe from both directions, we conclude that the limit x plus 1 as x approaches 2 is equals to 3. We can say equals to 3. Why? Because the value we have here and we have here are almost just approaches 3. So we will conclude the limit of x plus 1 as x approaches 2 is 3, or the function approaches 3. The function will approaches 3 as x approaches 2. So now such kind of expression or evaluating limit is called informal definition of limit, which is it takes time and difficult to understand. Thus we have the formal definition of limit. So the formal definition of limit, or sometimes it is called epsilon delta method. So by limit as x approaches a, f of x is equals to or approaches L minus, for every epsilon greater than 0, there exists one value of delta which is greater than 0, such that when absolute value of x minus a is less than delta, then f of x minus L is less than epsilon. Which means that if this one is true, if this happens, then this will be true in a sense. Now we'll justify for each term for this statement or definition. Delta and epsilon are very small positive numbers that represent delta values of distance from A to the left and values from A to the right when x approaches to A, and epsilon represents the distance to up and down along y-axis when f of x approaches L. So in short, as epsilon and delta are Latin words actually, which represent for, or we will use in this definition to represent a very small positive numbers or the distance. So again, 2 by x minus a less than delta means this is minus delta. It is between minus delta and delta, since the definition of absolute value. This is defined or comes from the definition of absolute value, which is, and now solving for x to left alone x, will add a at all direction. So finally we have from the left we have this one, a minus delta, comma, a plus delta. This means that a plus delta means all the values of x when approaches a from the right. Again, a minus delta are all the values when x approaches a from the left. The same is true, same thing. By absolute value f of x minus L less than epsilon means, which is equivalent with this expression using the definition of absolute value. So having simplified, finally we will get this one, which means that x plus epsilon and x minus epsilon. This is the same. So this is the same with the a minus delta comma a plus delta. Again, the same is true. We have this is along the y-axis, L minus epsilon comma L plus epsilon. So this is the radius, by the way, up and down, and this one is the radius left and right in sense. Yes. Now we have the above remark. We are going to compare the difference between the formal and informal and formal definition of the limits using a counter example, which is by limit x approaches a, f of x equals to L means this is the formal definition of limit. Everything here, every term here, it has its own meaning, as we have justified in the above remark. So this is in short what you call the definition of the formal. So let's try to compare what the difference between the formal and the informal definition in sense. By this means, or the limit of f of x as x approaches a equals to a, means using the informal definition as x approaches a, then the function f of x approaches a. But in the formal, for every epsilon, there will be at least one delta which is greater than 0. The same is true, such that absolute value of x minus a less than delta whenever f of x minus L is less than the epsilon 1. Again, when substitute the function by x plus 1 as x instead of a, x approaches 2, that equals to or approaches 3 in a sense. So we'll define using the informal one, x approaches 2, then the given function f of x will be approaches 3. Please don't say it is equals to 3. No, it's forbidden. So again, for all epsilon greater than 0, there will be at least one delta which is greater than 0, such that x minus 2 as at the place of a we have 2. So x minus 2 is delta less than delta. The same is true, f of x is less than minus 3 is less than epsilon. The same is true as x approaches a. Again, by this definition, using informal, x approaches to the right. Again, the same is true. Let's say as x approaches a in a sense, for example, by counter example, as x approaches 2 means as x approaches from 2 from the right, as x approaches 2 means x approaches or numbers or values between 2 and 3, such that 2.1, 2.01, 2.001. And again, as x approaches 2 in a sense, x approaches 2 from the left. This means that values between 1 and 2, which means that 1.9, 1.99, 1.99, and etc. But in the formal one, as x minus a less than delta in a sense, it is a minus delta comma a plus delta. So as x absolute value of x minus 2 less than delta in a sense, it is 2 minus delta comma 2 plus delta. 2 minus delta in a sense that represent the general values, such as for this one, or in another one example of this value is this group of numbers. Again, for 2 plus delta is this value. Again, as f of x approaches L in a sense, this is the same is true as f of x approaches L from the upper and from the lower one. Again, in the formal one, look, By this mean, the corresponding definition formal limit is absolute value of f of x minus L less than epsilon. When you simplify this one, this is L minus epsilon, comma, L plus epsilon in this sense. When you simplify the absolute value using the rules of absolute value. Again, with counter example, as f of x approaches 3, in a sense, we have two chances as f of x approaches 3 from the right, I mean from the up, and as f of x approaches 3 from the lower one. From the upper, we have the as example as counter example is 3.1 or 3.01, 3.001. From the lower one, 2.9, 2.99, 2.99, and so on. Not all. These are not fixed values. This might be maybe I chose this one. Someone maybe choose another value. Again, I can choose this one from the left. It is not fixed answer, please. But the values should be from the left instance, values between 2 and 3. And from the upper instance, values between 3 and 4 in general. So for those of the values from the upper, we can represent using the formal definition using this general one. And for those of the values from the value 3 minus epsilon from the lower. This is the key difference between informal definition and formal definition of limits. So we have some exercises related with this counter examples. That's it. In a limit as x approaches 1 to x plus 1 approaches 3. So from the definition of this one, what do you mean x by the symbol in this sense? By the symbol means which one of the following is correct in this sense. So this means that x approaches 1 means as x approaches 1 from the left and x approaches from the right. As x approaches 1 from the left means values between 0 and 1. And as x approaches 1 from the right in a sense, values between 1 and 2. So which one is correct? Is it x equals to 1? No, forbidden. X equals to 9? Yes, this one is from the left. Again, x equals to 1.1. Yes, this is values from the right, which means that values between 1 and 2. Again, D, 0.89, this is also yes. This is the value from the left. But E, x equals to 2, which is beyond 2. It is not near to x approaches 1 from the right. It is beyond. It's large, but it's approaches, but it's larger. So the correct answer is B, C, D, but not E. Yes. So from the definition, as x approaches 1 means either from the left or from the right. From the left, values between 0 and 1. From the right, values from between. Same for number 2. From question number 1, from the given limit, or as x approaches 1 means which one of the following are correct? The same is true. As x approaches 1, using the formal definition in its sense, it is the absolute value x minus 1.01 less than delta. No. As x minus 1 less than delta, this one is correct. Again, 1.1 minus delta, 1.1 plus delta. No, this is beyond 1. It is beyond 1. But D, 1 minus delta, and 1 plus delta is the correct meaning, or or so instead of this is the formal definition. Look guys, this one and this one are the same thing. When you simplify this one, this using the absolute value, we will get this one. What is the importance in a sense? This represents for the left one, the values for the left one. This represents the value for the right one. So this is from the formal one, but for in this one is in the formal representation. Again, the same is true. Exercise 3. As x approaches from the right or from the upper, means which one of the following are incorrect? This is incorrect in a sense. As x approaches 3 from the right in sense, this is all values between 3 and 4. So we will choose the correct one, which is A is incorrect. As x approaches 3 from the right in a sense, we cannot represent 4. B is correct. Values between 3 and 4. C is incorrect. 3.008 is the correct one. This is the correct one because the value is between 3 and 4. Again, D is correct. So E is incorrect. F is incorrect. Why? Because this is from the left. So as x approaches 3 from the right, the incorrect answer is A and E and F, because E is forbidden. As x approaches 3 from the right in sense, it does not mean x equals to 3. And F is also 2.99. This is the value from the left. So 3 of them, A, E, and F, are incorrect as x approaches 3 from the right. Exercise 4. Absolute value of f of x minus 3 less than epsilon minus, which are the possible answers? Which one of the following are possible answers? A. Absolute value of x minus 3 equals to epsilon. B. 3 minus epsilon less than f of x and 3 minus epsilon. This means that what you call the correct answer. And again at C, 3 minus epsilon and comma 3 plus epsilon. Or D, numbers between 3 and 2. E, numbers between 3 and 4. F, A, and B. So which one is possible answer? Possible answer is B and C. Again is D, again E are the possible answer, except A and another one is. So these are the correct, possible answers. Why? Because the B and C are the same things. Again, 3 minus epsilon and D are the same things. Again, 3 plus epsilon is the same as with numbers between 3 and 4. Yes, so these are correct or the possible answers. Again, we have additional exercise which is proved using the delta epsilon method. proof that the following limits using the delta epsilon definitions. We have listed a lot of exercise. So we'll see one by one. Solving the delta epsilon or epsilon delta definition means just forming. We are going to be proof by forming a relation between delta and epsilon, having the fact from the definition. Let's say, for example, proof number one. We want to show that we will see this limit as x approaches to for 8 is equals to 8 using the definition. So we will show that for every epsilon there will be at least one value of delta greater than 0, such that whenever x minus 2 less than delta, then f of x minus 8 is less than, which is less than epsilon is true. Now from this starting from f of x minus 8, then instead of f of x we will substitute 8, since at the place of f of x we have 8, so I have substitute 8, then 8 minus 8, this is 0. So absolute value of 0 is 0, then 0 is less than epsilon, or epsilon is greater than 0, which is true as we have stated for this one. Yes. Again, the same is true for example 2. This is the formal definition. Using the formal definition, we will see, or we will prove if this one is true. Then we want to show for every epsilon, greater than 0, then there exists one value of delta which is greater than 0, such that whenever this happens, then this should be true. Yes, it should be true. So we'll start from that one. 2x minus 3, we have substituting the value of the function and subtracting as its approaches for the value of L, and we have finally these values. Then 2 we have absolute value of 2 is just 2, but instead of absolute value of x minus 3, we will substitute the delta since from the definition we have shown this one instead of this one, having this fact. So instead of absolute value of x minus 3, at the place of x minus 3 we have substitute this delta value, which is 2y of delta less than epsilon, implies this is delta less than epsilon over 2. Hence the limit of 2x minus 6 as x approaches 0 is true. So we can check it. To be back having this value from starting from the final one. So by this means 2y of delta less than epsilon, 2 we have this one as it is, then x absolute value of x minus 3 0, so we have substitute for the delta, again multiplying, and finally we will turn back to the original formula for the delta. Do the same thing also, for number 5, for example, as x the limit 1 over x minus 1 as x approaches minus 1 over 2. The same thing, everything is written from the definition what we have done. So we will prove on this relation, or this expression is, we will be prove it, this relation in terms of delta and epsilon. So having this one, minus 1 plus 1 is just plus, then 1 over x, so combined like this one, the LCM, the x. So we will pull out this minus 1 in order to have the values for this one, or in order to be matched with this value, yes, with this one. So I have two. So in order to be matched, so I have pull out minus 1. So rearranging, then x minus 2. This is my interest. This is why I have pull out minus 1. So I have, this is multiplication. We have the multiplication one here. So by the property of the absolute value, I have separated two absolute values, this one for this one again. But instead of this one, it is delta. But we will assume for this one, we remind to substitute this one. Now let's choose the value for the value, or instead of for the expression, just we'll substitute delta, this one. But what value will be substituted instead of this one? So for this solution, now let's choose delta is equals to 1, since from the above or from the definition. So from the given definition, from the above, as we have choose delta equals to 1, so instead of delta we have substitute 1, this one. So this is by the definition of absolute value. This means that this is x minus t is between minus 1 and 1. And solving this absolute value, finally we have 1 minus x will be between 1 and 3. Between 1 and 3. So we will multiply by 2. So as to have tx, since we have tx here. Yes, we have tx here. So we will be multiplied by 2 all the terms we have. So again we will divide it by 2, or inverting the values. Making reciprocal, and the sign is alternatively. So 1 over 6 less or equal to, less than 1 over tx less than 1 over 2. Rearranging, we have such one. So at the place of 1 over 2x, this one is greater than 1 over 6. So at the place of 1 over tx, we will substitute this one, 1 over 6. So rearranging, in another word, this is delta less than 6 epsilon, which is proved, and the delta is a minimum 1 or 6 epsilon. Again, example 7. The same is true as I have proven for the above examples, substituting the value. But here, after substituting the value of f of x and rearranging, so it is minus 5. So I have multiplied by the reciprocal. The rationalizing. So I need to have x minus 25. Then multiplying both of the numerators, so I have x minus 25, and then the denominator is, so the denominator is radical x plus 5. So at this stage x minus 25, in a sense, the value represent for the delta. Instead of this value, I have substitute delta over absolute value of radical x plus 5 less than epsilon. Likewise the above example. So now we are going to choose delta is equals to 1 to find for the value of radical absolute value of radical x plus 5. Instead of what would be the value. So I have chosen delta is equals to 1. So rearranging, at the place of delta I have subset 1. I have subset 1, then follow the same ways as the above examples, rearranging, solving for the x. Finally, we have this one. So finally, we have this one. So in all terms, we have insert square root, since in the term, my interest is just substituting for this one, and this have the expression radical x. So to get radical x, I have insert 3 of them under square root. The radical, I have add also 5 in all cases. So we have, so as to have radical x plus 5. Finally, this is delta less than radical absolute value. So instead of this value, so the lowest one we have taken for the above, this value is less than this value. So instead of this, we have substitute this one. We have this one already from the start to have, since it is proven. These all examples are about the limit, given the limit. So we have proved the delta epsilon method. How to check. Yes, thank you for playing this channel. Just subscribe and share to other friends and to other departments which takes this course.